Okay guys, 7.3 Part 1, Binomial Radical Expressions. We are going to look at adding and subtracting radical expressions today. Okay, example 1, add or subtract if possible. That if possible means we need to have the same root and the same radicand. The radicand is the stuff underneath the radical. Okay, so the same root and the same radicand. So looking over here at A, square root of xy. Square root of xy. You notice I'm not looking at anything else yet. Square root of xy, square root of xy, they work. Okay, so now I'm going to treat whatever is in front of it as if it's a coefficient of a variable. That's not what's going on. That's not what its official name, I should say, but that's what you're going to do. So 7 plus 3 is 10, and then you keep the square root of xy. That adding them together does not change it. This would be like having 7 square roots of xy's lying around, and you find 3 more square root of xy's lying over in your kitchen, and you bring them all together. Now you have 10 square root of xy's. Corny, but it works, hopefully. Okay, so now we take a look at part B. We have a cubic root of x, cubic root of 5. Well, the root is the same, but the radicand is not, so therefore this one is not possible. Okay, we cannot combine those. So this would be simply written as 2 cubic root of x minus 2 cubic root of 5. I want you to write down what it would be. You just can't bring them together. Okay, I should put over here not possible to, I'm going to put go further, right? In this case, it's subtracting, but not possible to go further, so that the original expression is the final expression. I don't know if I made that clear enough in class, and so hopefully that makes more sense. Looking at the word problem, and for some reason I was thinking that this is not the one I wanted to go over. The rectangular window shown below is made up of 3 equilateral triangles and 2 right triangles. The equilateral triangles have sides of length 4 feet. Okay, so that means in each one of these, this is 4, 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 and this is 4. And this is cut in half. So, and another thing is because this is a rectangle, we know that opposite sides are congruent. They are the same length. Taking us back to some geometric terms. So this is 8, so this must be 8. If this is 4, 8 minus 4 is 4. So this would be 2, and this would be 2. Okay. Now it says, what is the perimeter of the window? Well, we know that this is 8, and we know this is 8. But what are the sides? Okay, so now we need to pull this triangle out. Okay. And we know the hypotenuse is 4. We know this leg is 2. We want to find what this is. It doesn't say to use this in simplest radical form, but I think it would be a good idea to practice it just because of the things that we're looking at. Now, one thing you might not recall is that this has the properties of a 30, 60, 90 triangle, because the 30, 60, 90 triangle had 1, 2, and then root 3, right? So this is going to be 2 root 3 without doing any Pythagorean theorem work at all. For those of you who don't remember it though, you would want to do 2 squared plus x squared equals 4 squared. So 4 plus x squared equals 16. subtract 4 from both sides. X squared is 12, square root of both sides, and we know that factors of 12 are going to be 4 and 3. The square root of 4 is 2, so we have x equals 2 root 3. Look how knowing this property here saved so much time. And again, it's not a big deal except for when you're doing an ACT or another timed test where time is of the essence. So this would be 2 root 3, and this over here would be 2 root 3. So 8 plus 8, 16. And then we have 2 root 3 plus 2 root 3. These are like terms. They have the same radicand. So 2 plus 2 is 4. 16 plus 4 root 3 is the final answer. There is nothing else that you can do there. Okay? All right. Now, moving on to the final example, and we have, excuse me, simplifying before adding or subtracting. Got a frog in my throat. Ribbit, ribbit. Okay. Now, root 20, root 45, root 80, they're not like terms. They can't be added like this. But 20 is not a prime number. It's a composite number. So is 45. So is 80. 20 can be written as 4 times 5. 45, what comes to mind is 9 times 5. And 80 is, okay, this is 5 and this is 5. So I'm wondering if there's a theme here. 80 is divisible by 5 because of that 0. And for those of you who don't know, I'm going to pull up the calculator to show you. 80 divided by 5 is, oh, hey, what happened? How come it's not working? Oh no. Okay. I have no idea why it's not working. Let me try one more time. If it doesn't work this time, I don't know what. Okay, 80 divided by 5 is 16. That is one that is worth memorizing, okay? Definitely worth memorizing. 80 is 16 times 5. That is where you see it most often used. Okay, so now this is then 3 square root of 4 times 5 minus square root of 9 times 5 plus 4 square root of 16 times 5. Well, hopefully this one's easy enough that you don't have to do the factorization on it, but if you do, you could do the 2 times 2, 3 times 3, and the 4 times 4. And you know that that's a pair, this is a pair, and this is a pair. And that number needs to be taken outside, out front, right? So now on the far left, we have 3 times 2 times the square root of 5 minus, we pull that 3 out, and I should mark these out when we do that so we know what we have left. Square root of 5, and then we have plus 4 times 4, and then square root of 5. Now we have 6 root 5 minus 3 root 5 plus 16 root 5. We all have square root of 5. Those are all like terms. So we've got 6 root 5s, take away 3 root 5s, and then add 16 root 5s. 6 minus 3 is 3. 3 plus 16 is 19. 19 root 3 is your final answer. Now sometimes they won't all combine into one single term. You might have 2 separate like terms or 2 terms that have the same radical, and then you'll have a third one that is its own thing. That's okay. You just write it out and simplify it as far down as you can, okay? That concludes today's or this part's lesson. So see you later.